Hello and welcome to yet another video of Cornerstones of Math. When a is less than b and b is less than c and x is real, solve the inequality. Absolute value of x minus a is less than absolute value of x minus b, and absolute value of x minus b is less than absolute value of x minus c. And I will solve this inequality in 3 different methods. They are all super cool and important methods, obviously, and actually one of these 3 methods will come quite handy when solving other types of inequalities as well. So please stay with me till the end to learn all those neat tricks. We first start with popular algebraic method. You see, the main trouble here is that we have absolute value notations. And one of the most common ways to get rid of this absolute value is by dividing into 2 cases. For example, for this absolute value of x minus a, if x is greater than or equal to a, then this x minus a is non-negative, so we simply have x minus a. But if x is less than a, then this x minus a is negative. So in order to make the entire thing positive, we have to write minus x minus a, which is a minus x. In this problem, we have 3 different absolute value expressions, and given that a is less than b and b is less than c, we can divide the problem into 4 cases. X is less than a, x is greater than or equal to a and less than b, x is greater than or equal to b and less than c, and x is greater than or equal to c. So basically, these 4 regions represented on a real number line. Now let's examine each case, and let us actually start from the right. So for the first case, if x is greater than or equal to c, then these x minus a, x minus b, x minus c are all positive, or at least non-negative. Therefore, we can write simply x minus a is less than x minus b, which is less than x minus c. And notice that x, our unknown variable, can be cancelled out. Then we have minus a is less than minus b and minus b is less than minus c. However, this is impossible because it is given that a is less than b and b is less than c, and thus minus a is greater than minus b and minus b is greater than minus c. Therefore, there is no solution for this case. Case 2, if x is greater than b and less than c, then x minus a and x minus b are still positive, but x minus c becomes negative. Therefore, the absolute value of x minus c is given as the opposite sign of it, c minus x. This system of inequalities is equivalent to x minus a is less than x minus b and x minus b is less than c minus x. Here we can also immediately realize that this x minus a being less than x minus b is impossible due to the given condition a is less than b, which means minus a is greater than minus b. Therefore, there is no solution in this case too. Case 3, if x is greater than or equal to a and less than b, then x minus a is positive or 0, but x minus b and x minus c are negative, so we have less than b minus x and less than c minus x. Therefore, we have this. From this inequality, we have 2x is less than a plus b, so x is less than a plus b over 2. The other inequality, b minus x is less than c minus x, is always true because it is equivalent to b is less than c, and this is true because it is a given condition of the problem. Therefore, the solution for our case 3 is the common range between this and this, which is x is greater than a and less than a plus b over 2. Finally, if x is less than a, then x minus a, x minus b, and x minus c are all negative, so we have a minus x is less than b minus x, which is less than c minus x. So cancelling x, we have a is less than b and b is less than c, and this is always true because of the given condition that a is less than b and b is less than c. Therefore, the solution for case 4 is the common range between all real numbers and this range, which is just x is less than a. Alright, so far we have obtained these. Therefore, the range of x satisfying the given inequality is the union of ranges a and b, which gives x is less than a plus b over 2. And this is the answer. The second method also belongs to the category of algebraic methods, but we will use different method to remove absolute values. You see, when you square the expression with absolute value, you can simply remove the absolute value parenthesis, regardless of the sign of whatever expression inside the absolute value. So we are going to square them. Normally, you need to be very careful when squaring all sides of inequalities, because the direction of the inequality sign is not always preserved, especially when negative numbers are involved. But in our problem, we have absolute values, so absolute value of x minus a, absolute value of x minus b, absolute value of x minus c are all non-negative, meaning that squaring them does not change the direction of inequality signs. That is, we have x minus a squared is less than x minus b squared, and this is again less than x minus c squared. So we have x squared minus 2ax plus a squared is less than x squared minus 2bx plus b squared, which is less than x squared minus 2cx plus c squared. And cancelling out x squared, we have another system of linear inequalities. Minus 2ax plus a squared is less than minus 2bx plus b squared. And minus 2bx plus b squared is less than minus 2cx plus c squared. So let's start from the first one. From here, 2bx minus 2ax is less than b squared minus a squared. So 2b minus ax is less than b minus a, b plus a. And since b minus a is positive, we can divide both sides with 2b minus a, and the direction of the inequality sign remains unchanged. So we have x is less than a plus b over 2. Next, from here, we have 2cx minus 2bx is less than c squared minus b squared. 2c minus bx is less than c minus b, c plus b. And since c minus b is positive, we can divide both sides with 2c minus b without changing the direction of the inequality sign. So we have x is less than b plus c over 2. So now we have to find the common range of these two. And from the given condition a is less than b and b is less than c, we can easily find that a plus b over 2 is less than b plus c over 2. So on the number line, each range looks like this. Therefore, the common range of 1 and 2 is x is less than a plus b over 2. So we arrived at the same answer. And now the epic third method, using graphs. You see, we can plot the graph of y equals absolute value of x minus a, knowing that y equals x minus a when x is greater than or equal to a, and y equals minus x plus a when x is less than a. So we can obtain a graph that looks like this. And we can do similarly for absolute value of x minus b and absolute value of x minus c. Here we have to remember that a is less than b and b is less than c. So these three graphs looks like this. And you can easily find that this coordinate is a plus b over 2 and this coordinate is b plus c over 2. Now we have to find the region where this inequality is satisfied. That is, the region where three graphs are positioned like this. The graph of y equals absolute value of x minus a is below the graph of absolute value of x minus b, and the graph of y equals absolute value of x minus b is below the graph of y equals absolute value of x minus c. From the figure, we can find that this region is given as this. When x has these values, the blue graph is always below the green graph, and the green graph is always below the yellow one. Therefore, the solution is this region, which is x is less than a plus b over 2. And that was the graphical method. And that's all for today's video. Thank you all for watching. And if you enjoyed this video, please hit that like and subscribe buttons and explore more interesting math videos of my channel. And I will see you in another video.